Hello everyone. So today the problem which we are solving is process string with special operations 2. So what is the problem stating? You are given string s consisting of lowercase English letters and special characters star, hash and a modulo, right? You are also given an integer k. You need to do is build a new string result by processing s according to the following rules from left to right. So if a letter is lowercase, append to the result. If there is a star, remove the last character from the result. If it exists, a hash duplicates the current result and appends it to itself, and a modulo reverses the current result. Okay, so you need to return the kth character of the final string result. So if k is out of bounds, return a dot, right? So I guess the problem, if you see the first problem statement, the first problem of this contest, so it was almost the same. The only difference in this was you need to print or you need to return the string only, right? So if you closely look now, what we did in the first problem of this contest was we traversed on the whole string, right, the s which was given to us, and if we got a hash, we made a copy and appended it. If we got a modulo, we just reversed the string. If we had a star and it was not empty, we did a pop, right, we removed the last character from the string, or else we did append that character to us, and at the end we returned the string which was given to us, right? And if you look to the constraints of this, it was only till s dot length was only 20, right? So even if you had written a recursive solution which was exponential, because doing these things like reversing the string or appending the string, it would be a little costly, right, in terms of time, right? So if you look closely, this would work for these constraints. But in this problem statement, I need to return the kth character from the string, and if you see the string's length, it is till 10 k power 5. What does this mean? This simply means that your string could be very large, right? And if you see k is till 10 k power 50. So this in itself gives us a brief hint that we can't find the complete string result, right? You can't find the result string because it will be very huge, right? So what can we do? And more, if you think so, you need to write a solution which does not involve in uh, going from 0 to k, right? Because if you go to from 0 to k, and if k is as big as 1e15, right, it will give us a TLE, right? Okay, so what is the approach then, right? So if you closely look at the second test case now, I will try to explain it with you with this second test case, but let me clear the idea first. So if you see which operations are being given to you, right, and if you try to compute the length, right, if you try to compute what is the length of my string, compute length of string, right, length of string, and if the length which you found out, right, what I'm trying to say is, let's say you had cd, right, and after following these operations, whatever operations are there, if you uh, do all those operations, and after doing that operation you are just having a number, that is your length, right? So if your length is at least bigger than k, then you can definitely print an answer, right? I'm not telling what will be the answer, but you can print an answer, right? You can do a cout or you can return the answer, right? Else, if you don't have a string of length at least length, right, that means you can't access the kth character, right? So what will you return? You will simply return a dot, right? Okay, so how let's first think of calculating the length, and then I will try to tell you what is the significance of finding this length, right? Let's say I had this test case, right? Okay, uh, let's say we had this test case, right? So if you look closely to it, if you had a c, what will you do? You will add c to it. If you add a d, you will add d to it. What is the modulo operator doing? Modulo operator, it reverses the result. You had a result of cd, it will become dc, right? Okay, then you had a hash. What will hash do? It will duplicate the result, right? So let's duplicate it. DC is duplicate is DC, and add a DC to it, right? Okay. Then what is next? Sorry. Next we did a hash. Now star. What is doing star is doing? Star is deleting the last character, right? So we'll delete the last character and again a hash. That means append the string which you got, DCD and DCD, right? So I think calculating the length will be pretty easy, right? What is the process of calculating the length? Let's first look at it. So we will be traversing from 0 to n, that is the string's length, right? And if we are storing ch as our character, right? If character is equal to hash, right? If you had a hash, what you are doing? You will simply see we had a hash now. At this point we had a modulo, right? At this point we had a hash, right? First we had a hash. So DC, after that we had a hash, and hash did what? It multiplied our length by 2, right? Okay. So if we had a hash, multiply the length by 2, right? And if we had a star, we were deleting one character. If you delete one character, what will happen? Let's say we had length, you deleted one character, length becomes length minus minus, or length minus 1, right? So we will be doing the same thing. If length is greater than 0, what does this mean? If we had any character, then only you can delete, right? So do a length minus minus. And if is lower, because in the given constraints it was clearly mentioned that characters will be in lowercase alphabets, right? So if the character is a lowercase alphabet, then you can do a length plus plus, right? Okay. So first conditions is that if your length is less than equal to k, that means simply you can't find the kth integer in your string, you should return a dot, right? Now let's talk about this process, right? What is my approach, right? Let's look about my approach, right? My approach for this problem is reverse engineering, right? What is reverse engineering? See, when I came to know that my length can be greater than k, that means I will surely get an answer, right? If I surely get an answer, why not let's try to find the answer? But you can't print the string, right? You can't have a string, right? So how will you do it, right? See, I think the first hint to this problem was the constraints 10 k power 15. That purely means that you can't traverse on the string, right? So what I am trying to do is I will calculate the length, right? And I will do reverse engineering. What does this mean is we will start from the end of the string, right? Let's say I had a string, this one, right? This string, right? Let's take this case. So I had this test case. What I will try to do on this is do a reverse engineering. I will get a length, right? Or rather take this one, because we have already found the length. What will be the actual length of it, right? So let's take this case, right? Okay. So what is this test case denoting us? It says I had got a length of 6, right? Length equal to 6, right? Now if you closely look at this, I will do reverse engineering. I will start from the end. Why will you start from the end? Because see, I already found a length of 6, right? Now I want to reach a length of k. If my length is equal to k, that means I found the answer, right? So I will start from the end, and as I have a length of 6, I will try to deduce my length to get to this point, right? And if I get to this point and this is a English alphabet, right? If this is a alphabet, then I will return it. See, not just reaching on this is a point, this should be an alphabet as well. Alphabet means is lower character, right? So these are the things which I need to take care of. I repeat, see why, if you have any doubt on this portion, listen carefully, that why are we traversing from that, right? This would be the biggest question which you will be thinking of it, right? See, I got a length of 6, right? Now I know for sure this string will give me this string will result in a string which will be of at least length equal to 6, right? This means if I traverse on the whole string, I will get a length of 6, right? And after doing that, right, after getting a length of 6, I will try to deduce or reduce my length to k, right? And if I get to the point k, that means that is my strings, that is my answer, right? So that is what I am doing. So that is the reason we are traversing from the end. See, if you start from the start, right, you might have a question, right, that why not let's take a length equal to 0 and start from the start, right? If you do so now, you will get so many confusions on the way, that if the string is let's say you took cd, then it reversed, and you will not have a length, let's say length equal to 2, and at that point how will you manage k equal to 3? You don't have an index that will show you that okay, length 2 is matching with 3, right? So that is the sole reason we are traversing from the end, right? I hope I am able to make sense why I am traversing from the end, right? Okay, so we will be starting from the end, and we will do whatever the question said, like let's say it in hash it said copy, right? If we are doing a copy, length becomes length into 2, right? So when we will do reverse engineering, we will do length equal to length by 2 for it, right? When it say a delete, right, when it was deleting, right, we will be doing an addition, right? And when it was uh, reverse, right, we will just move the k index, right? Okay, this is the sole uh, these are the only things which we need to take care of. Now let's see the code, right? And this, why this will work, I have explained to you clearly that these are the reasons why this will work. Now before we will see the code also, and side by side we will also see what is the reason of doing that, right? So let's see, we are starting from n minus 1. I already explained why from n minus 1, right? And we will be traversing till 0th index, right? So the first constraint is if you got a hash, right? If you got a hash, do a length equal to length by 2, right? Okay. And one more condition is there. If k is greater than equal to length, do a k equal to k minus length. Now what does this mean? See, while actually when I was also solving this problem, I came across this logic, right? Let's say I had a b c d, right? And one more a, and I copied it, right? And I did a b c d, right? And initially my k was equal to 6, right? 0 1 2 3 4 5 6 7, right? So if you look clearly now, for k equal to 6, it is pointing at this pointer, right? At this, which is answer equal to c at this current moment, right? And if I came to a hash, right, that means I will reduce my length by half, right? My length was 8, right? So I will do a 8 by 2, right? What does my length become? Length becomes 4, right? So now if you clearly look at it, your k point, you want a point k as 6, and your length is only till 4. Now how is that possible? You just tell me, right? That's not possible, right? So what does this mean? Just move your pointer by length. See, why will this work? If you clearly look now, this is nothing but a copy of it, right? So if this part is a copy of it, and you are reducing from your current index, you are reducing that length which you have deleted, will you not think you will reach at this point? Think of this, right? You were at index 6, you reduce by 4. Which index will you reach? You will reach the second index, and second index points to c as now also, right? So I hope this part is clear to you, right? Why are we doing k equal to k minus n? See, if k was already abcd and abcd, and you were already pointing at this pointer, then you don't need to reduce your k, right? Even if you reduce your length, your answer is still in this margin, right? That is the reason we are checking first if k is greater than length, and if so, reduce the k's length as well, right? And why? Because see, copying it and then pasting it, right? And when we are doing reverse engineering, we know that okay, this part is nothing but few values or length value behind this index, right? Okay, so now if I had a star, right, I will simply do a length plus plus, nothing special. I already told you we will be doing reverse engineering. Why so? I have also explained that part, right? So if there is a star, I know I would have deleted in the actual case, and when I'm doing a reverse engineering, I'm just adding that length, right? And if I got a percent or modulo, right, I will do k equal to k minus 1 minus length minus 1 minus k. Why so? Now let's try to understand this. If I had a b c d, right, length is what? Length is 4, right? And let's say your k was pointing to this, right? K is equal to 1, right? And now you think, and now the operation which came was modulo. What would have modulo done to this string? Think of it. Modulo would have made this string as D, C, B, A, right? And now your answer would have become C, right? But K equal to 1 will point to C, right? So you need to smartly move your K in such a way that even if the string was A, B, C, D, your K would have still make sense and would have returned a C. Now how will you do that? If you see A, B, C, D, right, this pointer, it is, if you move your, see what happens when you do a reverse string, right? A, B, C, D, it is nothing but a mirror, right? A, B, C, D, let's say, right? It was a mirror of it, right? So this string gets reversed because a mirror was there. It becomes D, C, B, A, right? If you see clearly, isn't it a mirror, right? So when you had A, B, C, D and this pointer was over here, K equal to 1, now you should move your pointer to this K, this pointer, right? And what is this? This is nothing but, if you clearly look, the length gets changed, right? So K equal to, we are processing our K, length minus 1, why is length minus 1? Because see, the index are starting from 0, 0, 1, 2, 3, right? So length minus 1 minus K. So your length was 4, 4 minus 1 minus K was 1. So 4 minus 1 minus 1, that is 2. So it will now correctly point to the C index. Are you getting it? Why I have done this? Let's take a bigger example, A, B, C, D, E, right? Let's take D was first our case, right? D 0, 1, 2, 3, 4, right? If your K was 3, now your length is 5, right? So 5 minus 1 minus 3. And if you clearly look, this should definitely point to this one, right? If you reverse it now, it will become what? E, B, C, B, A. So see, this is now the K which you're pointing, it was B, right? And if you look at this, it is also pointing to this B index, right? 5 minus 1 minus 3, which is nothing but 1. 5 minus 1, 4, 4 minus 3 is 1, right? So 0, 1. So now it correctly points to that index which we are talking about, right? So that is the reason we did K equal to length minus 1 minus K. And if you had a low, if it is already a normal character, a lowercase character, then I did a length minus minus, right? And finally we checked if K is equal to length. See, we are checking in the constraints that if it is a lower character, that is the only point you can return a result, right? So if it is a lowercase character and if your K has reached your length, or rather your length has reached K, right, at that current moment you will simply return the S of I, right? And ultimately you can return any value. It might not come to this point anyway, right? Still you can return a dot, right? So I hope this problem statement was clear to you. If you look at the time complexity, it will be nothing but big O of n, because we are simply traversing on the whole string, right? And neither we are taking an extra space complexity. So space complexity, this is our time complexity, and big O of 1, right? Sorry, big O of 1 is our time complexity, right? Big O of 1. Okay, so this was it for the code. I hope you liked it. If you liked the video, please do subscribe my channel and share it with your friends. Thank you for watching.